Today we are going to build TreeView component, similar to what we have in Material UI, but with some extra features. But before we start writing the solution, let's discuss what we plan to do. First, let's talk about what we need, and we will start from the requirements. Our top priority is to make a reusable component. This means no fixed code, so using it in another project or page won't be an issue. So our first requirement, the component should be reusable. Next, we want to display items as a folder structure, so you can tell which are the main ones and which are the sub-items. Let's all this show hierarchy. If we click on parent item, we should expand or collapse its child items. So the next one, expand collapse items. The next requirement is very similar to the previous. We include buttons at the top of the TreeView component, one for expand all and another one for collapse all. Next up, we want a search feature. If you find an item, it should stand out visually. We won't hide any items, just make it easier to see what you might want to open. If the search field is empty, we shouldn't highlight anything, so it will be like previous state. The next topic is our UI. Let's create simple design which we want to build. The first component will be search input, which will be at the top of the TreeView component. So let's add some field and add search input text. Under the search component, we'll have two buttons, expand all and collapse all. So let's add some text here, and it will be enough. The last component in our design is our tree. We'll have some buttons with text and icon. For example, folder 1, folder 2 are buttons, and file is just text, it's not a button, because it doesn't have any functionality. And also let's add some arrow as an icon. Let's try to resize it, make it a bit smaller, and we need to also rotate it, or just maybe find another one. Let's make it smaller, and it will be very close. It will be from the left side our folder. The interface shows us how our data should look. We won't use TypeScript, but it's still important to know what fields we need before we start coding. So let's add our interface here. Our interface will have name like tree node. So let's write interface tree node. Also, we want probably to align it to the left side because it's not very readable. So let's change it. Let's try to find how to do it, and yeah, it will be better. Our interface has two must-have fields, ID and name, both as text. Next is children, an optional field that can hold more tree nodes. Is expanded is also optional and will handle opening and closing items. So let's finish with children, and the next one is expanded. Let's write that it's optional and it will be boolean. Lastly, highlight is for making search result stand out. So let's add this optional field, and it will be also boolean value. Our interface is ready, and it will be all fields which we will use to implement our component. Let's also discuss the state of our app. I will use the useState hook. This hook can be used for simpler state management tasks. In our case, it will be used instead of a search input. UseReducer. This hook is used to manage complex state logic. It's used inside the TreeView component to handle actions like expanding and collapsing nodes. So let's write here UseReducer and useOnText. UseOnText can be used to provide state and dispatch functions down to nested components. Also, we will have something similar to lazy load functionality. It means that if the item is closed, we will not render it. So let's write here lazy load functionality. And the last one is accessibility. All actions should be available from the A-board. So let's add the last topic here. Let's write support accessibility, which will be fine for our simple design. We can always add more features or make it better later. In this video, I'm not just talking about the design, but also how to actually make it. I will use a React template from Bot for this. I added two symbols for our open and close buttons. We also have a style CSS file with just a few styles. I already prepared more data for our component, which looks similar to interface which we created before. Alright, let's begin by getting the data. We'll bring in a useFetch and useState for this task. For now, useState will hold our data to make our part, but later we will switch to useReducer. Let's also import fetchData function to simulate API all. So let's add fetchData from our data file. Next, we import the data variable and the setData function from useState. By default, data we build an empty array. Then we use useFetch to get our more data with fetchData and store it in useState. We won't put any arguments in useFetch dependency list, so it will fetch data just once when component is mounted. Let's use setData to store the data we get from fetchData. FetchData is what comes from our fetch function. We'll also add a console log to make sure we are getting the data. As you can see, everything is stored as expected. Now let's remove the console log and start making our UI. The first part we made is for search, but for now it won't do anything. Let's concentrate on making the TreeView component. This component will get data from props, so it won't fetch any data itself. This makes sure the component can be used again. As you see, we have added a TreeView component, but it's not made yet. So our next step is to actually build this TreeView. Alright, let's import the TreeView component and make a new file just for it. We have an empty file for our component. Now let's make two parts, TreeNode and TreeView. I will also add some class names for simple style. We will start by making the TreeView component. TreeView controls the whole tree, and TreeNode shows each item, nesting itself for sub-items. Alright, let's export the TreeView component so we can import it elsewhere. Now let's add some logic. TreeView will get its data from the parent component. Also don't forget to add some class name. Let's take a look at the name of the class name which we want to use and add it to the component. TreeView will get its data from the parent component. It will go through the array, and each item in the array will be used in the TreeNode component. So TreeNode gets each node as a prop. So let's add TreeNode component here and add node as a prop. Let's talk about our TreeNode component. It gets a node and will handle most of the user interface. Let's add div element with TreeNode class names. This div element will be used as a container for this UI. So let's add our class name TreeNode, and as a next step, we'll add a span element that shows the node's name. To speed up testing, I will use useState for now instead of useReducer. We will test it first, and then I will update the logic. Something went wrong. As you can see, looks like we have some extra symbols in our render. Let's try to delete it and refresh the page. As you can see, now we have our root name NBA. Now let's add our useState for this component with two variables. IsOpen and setIsOpen function with false as a default value. Next, let's add a toggle function. This will handle opening and closing items in our component. We will use the setIsOpen function to set the opposite state of the current isOpen value. Next, let's add a button for this open and close action. We will only need the button if the node prop has a children field. So if it does, we will show the button. The button will have an onClick function and a class name. I will use toggle icon as a last name. If the component is open, we will show one arrow. If it's closed, we will show a different one. Alright, let's take the arrows from the app component that I showed you before. We will put them in our component, so we know what the next action is, either to open or close. Next, we will display our tree. If isOpen is true, we will show the TreeView component and pass the children as a not props. So let's delete E, and here we need to pass not optional chaining children. And something went wrong again. Sorry, we are using TreeView here, not TreeNot. And as you can see, everything works as expected. Next, let's add buttons to expand and close all items. To do this, we'll go back to our main app component and add two buttons here. Let's maybe add some div element as a container for our buttons. And let's add two buttons to our div element with expand and collapse all buttons. Alright, let's give them new names and start working on the main logic. We'll use reducers and onText for this. We'll make a new file, tree.onText.js, that will handle this functionality. Let's open our file structure and create a new file, tree.onText.js. First, what we will do in this file, we'll create onText for sharing values between components. So let's write tree state onText and run create onText function. The next step is to export a new component, TreeView provider. This component will provide data and functions to its child components. It takes children and wraps them in a provider. Then it returns a new component that has the added logic. Inside the component, we are using the useReducer function. This gives us a way to manage our tree data and a function to update it, where state is a tree data and dispatch is our function. useReducer takes two arguments, empty array as a default value and treeReducer. It's a special kind of function that helps us handle changes to our tree data. Here we begin the onText provider. We are saying children components and access the state and dispatch values. So let's fix it and add value and pass the state and our dispatch function. And don't forget to include our children. So let's write here children, and now our children have access to state and dispatch function. The next step is to create a useTreeState. This hook lets components easily take the shared values from TreeState onText. To implement it, we need to write onText is equal use onText hook and pass the TreeState onText. We get the shared values from TreeState onText, so we just need to pass it. And don't forget to return it as well. Now we start defining a treeReducer function. It takes the current state and action. It will decide how to change the state. Based on switch statement, we are checking the type of action we got. This helps us decide what change to make. If the action type is init data, we'll return the new data that's provided in the action. If the action type is toggle node, we'll run a recursive function toggle node with the current state and details from the action to decide the new state. Our details will include ID of node and the state which we need to set. It can be open or closed state. Now let's implement our toggle node function. It takes three parameters, nodes, an array of data, ID, an identifier for specific node, and is expanded, a boolean to set the node's expanded state. We are going to iterate over each node in the nodes array using the map method and check if the current node's ID matches the given ID. If it does, we return a new object that copies all properties of the current node and updates the isExpanded property. Let's write isExpanded, and if the current node has children nodes, we run the toggle node function recursively on its children. This ensures that all levels of nodes get checked. So we just need to write children and run the same function, but with node children. If the node's ID doesn't match and doesn't have children, we simply return the node unchanged. This function's purpose is to find a node by its ID in a nested structure and toggle its expanded state considering all levels of depth. Also, don't forget to add default state for our reducer. To be able to use reducer on test in our component, we need to wrap it to the tree provider. So let's try to import it, and also let's import useTree state as well. So we will use this hook in our component. By being inside tree provider, it and its child components can access the tree state and actions. So let's wrap the main app to the tree provider. Now we can replace the useState by useTree state. We'll use useTree state hook to get the state and dispatch from our tree on test, which we implemented previously. Let's replace setData by dispatch with initData action and refresh the page to check if it works. So let's finish with this line, initData, our data. Let's also maybe rename fetchData to data just to simplify it, and we need to refresh the page one more time. So something went wrong. Let's refresh it one more time, but it still doesn't work. Let's maybe open another file and check if we have here any errors. Here we don't have anything. Let's maybe scroll up. And yes, we need just to call our reactJs function. And now it works. So the next step is to replace useState in our TreeView component. As you can see, we used here isOpen and setIsOpen. So let's copy our state and dispatch function. Let's maybe delete state because we don't use it here. We'll use just dispatch. And we need to import also useTree state hook. Everything what we need to do here is to replace our setIsOpen by dispatch function. So let's do it. Dispatch, and we need to add some type. It will be toggle node, and I don't remember the names of them, so let's check it. And we need to add ID and is expanded value. So let's do it. Node will be node ID and is expanded will be opposite state of node is expanded. And let's delete our useState here. Delete it, and probably we need to replace also isOpen by our new node is expanded value, which we created. And everything what we need is just to refresh the page and check if everything works. Yeah, it works as expected. Next, we need to make the expand all and collapse all buttons work. Right now they don't do anything. Let's take our dispatch function and add it to this button, but with different actions. So let's copy this dispatch and add it to our buttons, expand all and collapse all. So let's add on lead with this action, and let's delete some extra information, and let's change toggle node to expand all. And let's do the same, but for collapse all button. Let's copy dispatch one more time and add it to our collapse all button. Next, let's add the sections to our reducer and explain what we want them to do. Both actions are pretty similar. We'll go through all items and set is expanded to either true or false based on the action. So let's add our new actions to our reducer and add toggle all nodes function with false or true. Where false it means collapse all and expand all is true. So let's change here true on false and add a new action here, collapse all. Now it's time to implement toggle all nodes function that takes two arguments, state, which is an array of nodes, and is expanded, a boolean value whether nodes should be expanded or not. For each node in the nodes array, we'll return an updated version of that node. If the current node has children, we return a new object with the previous value of the node, and we set the isExpanded property of the node based on the isExpanded argument. So here we added the previous value of node isExpanded, and then we recursively run the toggle all node function for the children of the arrayed node to ensure all elements are also toggled. If the node doesn't have children, just update its expanded property and return it. And we need to change state on nodes. So now let's refresh our page and check if everything works. And it doesn't. So I guess that we need just to check if we have data using optional chaining, and it will be enough. So as you can see, both buttons were isExpanded, all and elapse all. The next step is to implement our search functionality. So let's open maybe the previous section and change elapse all to search. So let's change it. And new function search nodes, which will receive two arguments. The state, where state is our list, and query, where query is the result of our input. Alright, let's write search nodes with two arguments, state and action. We will use the for each method to go through our list, so we will update one field and at the end we return the updated list. So let's write our for each method and create a new variable should highlight, which will be responsible for our search result. First, we check if the query has any text. If it does, we'll see if the node's name has a query in it. Making sure both are in lowercase. So let's transform the node name to lowercase version, and using include we'll check if the query in it. Don't forget to transform the query to lowercase version as well. And I guess we need to add also else. Else will be just false. So if the query length is 0, for example, we'll return false. And we don't need to highlight any items in the tree. The isHighlight property of the node is set based on shouldHighlight variable. So let's write node.isHighlight is equal to shouldHighlight. Next, we'll check if the node has children. If it does, we will all search nodes again to look through the children. So let's write search nodes with two arguments, node children as a nodes and query. One more thing, if any child nodes are highlighted, we will set isHighlight to true for the whole tree from the parent down to the arrayed node. So if any children has isHighlight true, let's set isHighlight to true. So let's write it. And it should be enough for the search function. So let's check it. And I guess the idea to set the red color if isHighlight true will be good. So if isHighlight is true, all elements in the tree will have the red color. So let's add some inline styles, and if isHighlight true, we'll have red color. If it's false, just initial one. So let's refresh the page and check if it works. And it doesn't. I guess that we forgot to add any actions to the input. So let's add onChange function with some onHandleSearch function and add some handler here. Now let's describe this function. So let's create a new variable onHandleSearch, and this function takes event where the query is event target value. So let's create a new variable query where result will be value from the event. And I think that we forgot something. We need to save this query as a value for the input. So let's create new variables and handlers using useState. So let's create search query and set search query function to handle value of the input with default value empty string. So let's write set search query and useState with default value. So let's write set search query and useState with empty string. Also don't forget to add value to the input directly. Now let's all set search query function inside onHandleSearch and save the value for the input. To make search works, we need to dispatch search action and pass the query. So let's change data to query and check it. Let's click on expand all and it doesn't work. So I guess something wrong with this red line. To be honest, I don't see any errors, but maybe something wrong with... yeah, we don't have include. We need to change include to includes. And let's check it one more time. And as you can see, everything works. So if we put datum, all three will be red. If we delete this if statement with children, it will work only on the first level. We will not check any children, so it will work only for in-base string, but not for the rest of items. If we delete if statement where we check if any of the children is highlighted, it will highlight only item which we want to find, but not full path to the string. I think we added all functionality which we need, and we will not add any new one. So let's check all functionality one more time and expand all collapse all words, search words, so everything looks good. Even accessibility, because we use semantic elements. That's all for this video. If you have any questions or recommendations, let me know under the video. See you next time. Bye.